Hello, everyone, and welcome to the future of space. My name is Daniel Fox. Today we have Ian Fichtenbaum. He is the CEO of Bradford Space. He is the founder of Zero G Kitchen and has over close to 2 decades in the space industry. Ian, welcome to the future space. Is it close to or over 2 decades?
I guess it close to. I mean, if you can consider studying engineering and other preludes to actually diving into the industry, I think since let's see, I attended ISU in 2006 and I got into the space career in 2008. So that's 14 and 16 years. So getting not quite 2 decades,
And you were
but a
in
lot of it,
investment
a
before.
lot of it is. Hmm?
You were in investment before.
Well, it was investment. That is the industry that I was in. And that's how I got into the industry formally. Was getting into it on the investment side.
Now, you are quite well known for the kitchen at the space station and cooking cookies, but I think today we want to talk a lot about your current work, what you're doing with Bradford Space.
Yes.
Um, it's a pretty big endeavor, and then you have offices around the world, and you guys are pretty active. Share
Yeah.
with us everything that you guys are working on right now. What's the road ahead for you?
Well, I don't want to make it seem like I don't want to talk about cookies because who doesn't want to talk about cookies?
Yeah.
But what we're doing at Bradford is pretty exciting. So if somehow people's minds can get off the subject of cookies for a moment, then yeah, I'll talk about what we're doing and a little how we're doing it. So Bradford Space, we're I would say multinational. We're U.S. based, U.S. owned, but we're multinational in our operations. And that we have our operations in the U.S., but we also have operations in Europe and pretty extensive operations in Europe, in the Netherlands, Sweden, and Luxembourg. And in the U.S., we have in Seattle, and based in New York, which is our headquarters. And we also have some other operations in New York in finance and business development. We're established. We're established not only in operations, are established in terms of customers and products. We Our products tend to go into a lot of spacecraft and a lot of spacecraft that um, maybe you've heard of either commercially or in government in both Europe, well, in Europe, North America, and Asia, so across the board. And we tend to do things like propulsion systems. Propulsion systems are what we are most known for. But we also build attitude and orbit control components, little but important components for attitude and orbit control. And also, we actually built facilities for the space station. We're very known for the life science and the microgravity science glove boxes, which are very famous when you ever see the astronauts working on something in a glass box. Well,
Yeah.
we built that. We built that in our Netherlands facility. But Bradford today is very much, I would say, 80% of our company is propulsion and propulsion oriented, and a lot of that is taking us to where we're headed as a company, which is really mobility in space. Things you can do with a mobility in space. Because if you've mastered propulsion, and propulsion is not an easy thing to master, then you can start thinking about what can you do if you have this kind of mobility, and that's in today's market one of the most exciting things that we can be thinking about.
In terms of propulsion, what has been one of the biggest breakthroughs in the past 5 years in terms of technology? And do you think that the the industry or the technology of propulsion is due for a groundbreaking new chapter, because we've kind of been on this this period of where the technology has been getting better, but we it's still the same kind of idea of burning a gas, um, but we're confined with this reality. Are you seeing a world where there's going to be this major next step that's going to open a new era of propulsion?
So a lot of propulsion technologies date back a lot longer, a lot farther back than we realize. A
Yeah,
lot of it was worked on decades ago. Anyone who's read this famous book called Ignition by James Clark, wrote it in I think the early 70s. It just outlined everything that was being done from the 30s, 40s, 50s, 60s,
yeah,
and it's a lot of they were playing with lots of stuff, and a lot of stuff they developed. And so a lot of concepts that are coming to the market today, I'm not saying that all of them come from the 50s or the 60s, but a lot of concepts have had a long incubation period where somebody in some university or some large company has been working on it, those things for a long time. There's very little that's truly new.
yeah,
And even some of the newer chemistries that we specialize in, newer in the sense that they don't appear in ignition. They came to they got discovered a couple of decades later.
yeah,
Um, even that has taken a couple of decades to gain maturity and get into the market. I think probably the biggest thing that's happened in propulsion in the last 5 years, if you're just talking about the window of the last 5 years, one of I think, the biggest satellite constellation ever launched, Starlink, adopted the use of krypton as a propellant. And krypton had been, studied a long time, and it had its advantages and disadvantages. Most people focus on the disadvantages, which was its density. But one of the shifts was, when you're sending up hundreds and hundreds of satellites and or thousands of them, then you start caring about other things like cost of propellant, and that and a few other things is what made krypton the thing, and that's the shift.
yeah,
It's not a presto technological development. It's here's the use cases, or the use, not the use cases, but the use scenarios have changed a lot, and so you are inevitably driven to try different things, and new things that you otherwise would have dismissed.
Do you think nuclear is going to be playing an important role in propulsion in space?
We actually talk about this every now and then. I gave a presentation where, as a side note, it was, here's how you get to. Well, the main topic was here's how you get to Mars. So here's the propulsion technologies you want depending on your mode. And there are various things. None of them are nuclear, but as a side, I say nuclear is interesting, but we think you got to jump over to fusion,
Yeah,
and skip over fission. Nuclear. I've been on, at least mentally on nuclear for a long time. At some point, you just can't get the energy from the sun through photovoltaics. You're going far enough that you need nuclear, whether you like it or not. But nuclear is bulky. Nuclear is expensive. Nuclear is always going to have the Earth to orbit issue of getting through the red tape to get it up there. But even really just technically, there's a lot of heat that needs to be radiated out.
yeah,
And if you've ever seen some of these missions, uh, that have been architected around nuclear. Some of them just have enormous arrays of radiators
Yeah.
that you sort of wonder, well, what if all those radiators were instead, solar panels? I'm not saying you would get the same. You'd be right back where you were, but there's a definite trade for a lot of different applications of what really makes sense. So nuclear is interesting. Um, there's a number of different ways to do it. Um, I think you're going to end up making a lot more progress in the near term, looking at the more traditional chemical and electric propulsion.
Talking about that and the travel to Mars, recently in the news, it was the team that went to McGill. I think you went to McGill also.
I went to
The,
McGill, yes.
you went to McGill. So the old
Um,
laser fusion, it's a new technology. Do you have any comments on that news?
I don't know if I've even seen the news. So this is fusion by laser.
It's a new. Apparently, it would bring down the travel to Mars to 45 days, a possibility. So I will send you the link. But
Please
it's a
send me,
really
send
interesting.
me the link. I missed it, but it'd be interesting to see what they were doing in McGill. Maybe
Now
not while
you.
I was there, but
Well, there it's people from Luxembourg also, but
okay.
I've been to McGill, so and we all know that Luxembourg has a really they're extremely present in the space
Yeah.
industry. Now you were at FAA recently for the conference in Washington for the FAA
Yes.
conference.
Yeah.
What was the mood at the conference? Obviously, with everything that has happened in 2021, and everything that's happening, was there a collective excitement of new players to the table and what is happening?
Well, first, I think a lot of people were just relieved to be at a conference in person. So a lot of people were sort of getting. I mean, it's not for a lot of them. It's not like it was the first conference in 2 years, but for a lot of them, it's been sparse. So it was good just to see everyone. A lot of people there were a lot of it were various launch vehicles or tourist vehicles. I think what's new is the space stations. Now there's four companies that are effectively funded either by NASA or the capital markets to
Yeah.
build space stations, either standalone space stations or extension to the ISS. So there's now four of them, and they're starting to go around figuring out how they're going to do it, what's next, who's going to be using these things. There's a lot of figuring out to be done, but there's a lot of topics that have been around a while that they're moving the ball on. Space traffic management is been a topic for years. Debris removal has been a topic for years. Just how the policies are going to be set on um, launch sites and clearances. That's also a lot of things. I think a lot of people have what SpaceX is building down at the tip of Texas on their mind. That is probably more of a public interest
Yeah.
question more than whether the industry is thinking deeply about that. Industry knows that SpaceX is going to be launching a lot and launching something for a time to go. So whether they're doing it out of Texas or Florida is for the industry wise maybe neither here nor there. But there's a lot of interest in the public sphere about that. So I think again it was good to get out to that conference, good to just see people, and one thing that was fun to be at is they were because it was an FAA event. FAA has a wings program, commercial astronaut wings.
Yes.
So they had a ceremony where they were giving a bunch of those travelers from last year their wings. Um, Now, I was sort of again when I heard that that was going to happen. I heard it a few weeks before this. I said, "Oh, is William Shatner going to be there?" Well, William Shatner was not there, but Wally Funk was there,
What if
and a bunch of other
Dylan,
people were
yeah,
there,
Dylan.
and they were there. They got their wings.
But I understand that if I'm correct, it's going to be, I think, the last time that the FAA gives the wings because they're redefining what exactly are the terms of what is an astronaut. Because if you're just a pilot, if you're just a passenger not doing anything, so was there talk about that, or it's they're going to continue?
If there was, I didn't hear about it. I mean, I can understand where they're coming from because
Yeah,
when they started that program, it was really to award companies that had made,
yeah,
technical and operational progress. So it's going to go to either the test pilots or some of the very early passengers for braving the risks of it. And it was never really intended for the FAA, a government organization, to be the one to declare you've gone to space or not. It's not they never viewed it as that's their mission. So there was always going to be a point where they say, okay, we've awarded it. The industry is at least has gotten operational. It's gotten the maturity, and that's it's time to phase this into a new kind of program. That being said, I think for all the fascinating people that went up to space suborbitally and orbitally last year, I think they didn't want to miss an opportunity that they could give the wings to Jeff Bezos and William Shatner and Wally Funk and Michael Strahan. So I think their decision was pretty good to, cut it at this year and then just let the private sector figure out who gets wings from here on.
yeah. Absolutely agree. You were mentioning earlier that Bradford builds the vacuum containers and where some of the experiments are done. Um, just a quick parenthesis. Were the peppers you heard of the peppers that were grown on
The
the
peppers.
space station? Were they grown in one of your containers?
I don't think so. I got to look at a picture, but I don't think it's so. I should say they're not vacuums. They are negative pressure, but they're not.
Okay.
They're not vacuum. But I don't think it was the peppers grew in one of our boxes. They're too frequently used.
Okay.
Uh, to be brutally honest, for them to have just a pepper farm in there for an extended period of time. So I think that was it's a dedicated mission tray.
I see. But do you see actually the manufacturing of whether drugs or bioproducts in space being um, actually a source of revenue, a legitimate business in space because of microgravity, and now because we're gonna have more space stations, more environments, so that we can produce on on a bigger level.
I think so. It comes down to logistics, really. Can you build the things that you want and deliver them to whatever customer? I think a lot of I think a lot of manufacturing initially is going to be space for space, building in space for space use, and there's a lot of pretty high value applications for doing that. And It's not something we've done at Bradford. It's arguably we've done it. We did it at Zero G Kitchen because we manufactured a baked cookie there, and so I that you could consider our oven a small space factory, but it's obviously going to depend on just uh, logistics and a greater flow of just activity. More things, more stations, more people means you have more room to think about these kind of things.
Yeah. Now with the let's talk a little bit about the zero G kitchen. What was the
I
most
didn't finish about Bradford, but I'll talk about Zero G Kitchen. We can go back.
which you you brought it up a little bit, but
I know I brought it up, but well, go on. We can go to one and then we go back.
we'll circle back. What was the most unexpected challenge with the cooking the cookie in space? Something that obviously you would have never discovered unless actually doing it.
Um, it's not, no, there was nothing too unexpected. Going in, I knew, there were going to be bureaucratic obstacles and delays, and you have to go in expecting all that. And almost because we expected that, did we start off with the notion of, I want to do the simplest thing possible. I just want to bake a cookie.
Yeah,
That's it. I don't want to develop a cookie. I don't want to. I don't want to come up with a new formula for a cookie. I don't want to be a hero in designing a fancy oven. Although we did have to do real work in doing that, or at least
yeah,
our partners had to do work on that. But from the get go, it was um, build a thing that will bake a cookie. It may be something of that size and nature, um, and because we kept the scope as limited as possible, eating was a real controversy. You got a lot of press that the astronauts, you know, weren't going to eat the cookies. Well, frankly, if we had started off wanting the astronauts to eat the cookies, we would never have gotten this done,
yeah,
because this would have had to go through all sorts of reviews, and you know, uh, for what value? In the end, we wanted to bake a cookie, and
yeah,
it wasn't. And it was the same cookie that they had in the hotels that we were working with. So it was just a matter of taking that same frozen puck of dough
yeah,
and sending it to space. So that's a lesson of try to do the simplest things first, and go from there. And it's maybe a lesson we take to heart, or we can take to heart in Bradford, about how we're building up to, from propulsion to more complex and higher level vehicles. I've already led you back
I
to,
know. I was waiting for the pause to bring it back to Bradford because you've
to bring it
already
back to. I found a way back.
exactly. Maybe we
I
need
could be I could be asked about the cookies all day, but I got a company building out the solar system here, so I got to talk about that.
this is what we're here for. Now, so beyond the propulsion, you were talking. I mean, you just said moving around mobility. So, are you going into also the lunar vehicle rolling and individual jetpack? That can fly you around.
Okay, so when I say vehicles, I guess it means different things in different contexts. But I think of a space vehicle as something that moves around, sort
Yeah.
of non. Um, well, it means it's not moving around in the gravity well.
Okay.
So gravity well is you have to have a lander. It's you land on the surface. There are people working on that.
Yeah.
Our We spend our time more focused on going from orbit to orbit or doing things in orbit. So, and that means we can focus really on in space, mostly not thinking about an atmosphere, mostly not thinking about having to land on a surface. So, and in there, there's a lot of opportunity. The earliest satellites, especially the satellites going to geostationary orbit, they were all about get on a rocket, we're going to our orbital slot, and most of the propulsion I need is just to keep me in place. Um, or imaging, a lot of the propulsion was just keep it in that orbit,
Yeah.
or it was get it to the orbit. And so we thought of propulsion in terms of lifespan. This is the lifespan of the satellite. So they viewed putting in more propulsion as longer or shorter life, and sometimes you didn't want a longer lived satellite. Now there's a lot more interest in moving around. Um, Imaging, for instance, retasking, so that you can see certain things faster,
Okay.
or see certain things in different sort of time periods. So if you can retask, that's something that's a lot of great interest by users of imagery, or the customers of imagery. So there's a lot of interest there. Also now, there's more talk about how do you get higher resolution. Well, to get higher resolution, you got to get closer to the Earth. But the problem is going close to the Earth is you're experiencing more drag, and now that's even more unpredictable when there's solar activity. But there's more drag no matter what. So if you want that higher resolution, you need the propulsion. Um,
So
Real tight.
go ahead. So more propulsion.
More
More
propulsion. More
Yeah.
propulsion like that. You demonstrated propulsion.
Yeah,
That had some
exactly.
thrust.
I
Yeah.
totally pushed myself
Yeah.
to outer space.
Yeah. But okay, if you're talking about servicing a spacecraft, life extension, active debris removal, you certainly need propulsion because you need to approach, you got to do the thing, whether it's extending life or moving it. If you're talking about things around going beyond Earth orbit, the moon does not have orbits. There's certainly not the same kind of orbits they have around Earth. A lot more orbits are unstable, or they're weird things, and then you have to think about how do you go from the Earth to the moon. So a lot of that is going to need active propulsion and mobility. Um, if you want to have, if you just want to operate, or if you want to have any kind of concept of logistics. So as the industry develops, we're seeing we should we we have this expertise we've built, building thrusters, building propulsion systems for other companies, and then we see, okay, we'll still do that. We're absolutely still doing that. What can we build that nobody else can build?
Yeah.
Where can we go? Where can we push the limits? And we see that in our what we call our square rocket program. Um, that this is it, it's This has been announced, although it's been announced in a soft way. It's on our website, but it's not gotten a lot of press yet. But this is it's a transfer vehicle, and we said, how can we take some of our proprietary propulsion technologies and build a great vehicle, like a vehicle that is going to be, is going to have the capabilities in Earth orbit, in lunar orbit, in cislunar, going to Mars. How can we have that? How can we build that kind of spacecraft? And it combines the features that you really want, which is a lot of delta V. We think, in the future of space operations, you will never have enough delta V, because it's like, do you want more mileage for your car? Yeah, I want more mileage.
Yeah.
I want my car to go farther. I want its capabilities to be extended as possible, and you want to go, fast, um, which is sort of a way to say you don't want to go at a standard electric propulsion, electric thruster, speeds. There's very efficient electric thrusters out there. The market is almost flooded with them, with different companies, with different things.
Yeah.
But in the end of the day, for the true mobility applications, they're still doing their operations in weeks and months.
Yeah.
Um, and if we're talking about operations in Earth orbit and operations beyond Earth orbit, you don't want to be operating on weeks and months. You want to be operating hours, days,
Yeah.
weeks at most. And that calls for chemical, or it either calls for chemical or a very high power electric that we're not at that stage yet. So it
Okay.
really calls for chemical. So we specialized in a high performance chemical vehicle that can bring to bear all that kind of that delta V to do what you want to do. Now, there's a few other features in there. We didn't just take a vehicle and stuff it with delta V and high thrust.
Yeah.
It's built with some a design for manufacture philosophy. It's designed with easy instrument integration. It brings some lessons from some other large constellation builds. Um, and we're very, very excited about what it can do, or what multiple of these things can do. Because I this is sort of a strange boast, but I think a lot of the users out there for these things haven't even thought about what they would do if this existed, because it hasn't existed until now. So a lot of the people have to have to put their mind on what does this architecture, what architectures does this allow?
Is there like a secret Bradford formula of fuel that it's going to be on sale that the
Well, it's. I'd like to say yes, but it's not secret. It's not secret at all. I mean, we've been building thrusters on this for years, and this is based on the chemistry that we've developed. It's a propellant. Well, it's a green propellant. It has a name called LMP-103S. It's been under development in Sweden for the last 20 years. And we have built hundreds of thrusters on this technology. And it is now on 25 orbiting spacecraft. And this is propellant that gets up to 30% more energy density than hydrazine. And it has a wonderful property of being non-toxic, meaning it's transportable, it's handleable without scape suits, so it really cuts down that cost. But and that helps with the ease of integration and the prep for flight. But it's really that 30%
yeah.
higher performance or higher energy density that really gets us to where we're going. There's some other characteristics of this propellant that make it super interesting for what we're doing as well. That's a little more where secret sauce comes in.
Okay.
But it's, the stuff that we're working with is not secret. Um, People know that we have it. Other people use it, but nobody's building vehicles. Nobody has been taking it to build the vehicles that we're thinking about, and that's partly because some of these technologies you have to have an ownership. You have to have a mastery over if you really want to take it to the next level. So we're you know we're taking that base and going to that next level with it.
When you say that a propellant is green, what does it mean? Because a lot of people usually, they think as soon as you talk about fuel, no, it's not green. There's always a footprint to it. But so your propellant is green. What does it mean?
Okay, so we make no claims really about environmental impact because from our point of view, the propellant goes into the spacecraft, it gets launched into space, and it does what it's supposed to do. So we're not thinking about in terms of emissions
Yeah.
or particles in the air. It is relevant to when you're handling the fuel,
Okay.
um, but it's more of a personal safety and handling. To me, a lot of the talk about green propellants, um, it means different things to different people, and it means different things in context. There's some other propellants that are called green, but then some people dispute it, and it has to do with is it safe, is it good, or is it safe to use with you know a lesser degree of equipment and handling. Can you fuel it at the factory? Can you then send it to the launch pad? How careful do you have to be about certain things? You always have to be careful, but like,
Yeah.
how truly careful or do you have to be about certain things? How robust is it? And those things tend to define, in my mind, what's green or not. I don't think green really captures it because there's too many people will think of
Yeah.
it in terms of carbon emissions, and
Agree.
that's not that's not how we're looking at it. It really has to do with how robust is it as a propellant, and how you know how we can use it operationally.
Now it's
There are propellants that say, "Oh, it is green if you handle it properly." Well, what's proper handling?
yeah.
Turns out proper handling is a whole lot of stuff that bogs down your procedures or slows down the procedures, and doesn't make it a robust integration and launch process. If you do have if this allows you to have a robust integration and launch process, I think it's doing what it needs to do in terms of non-toxicity and green. Of course, keep you safe. That's also important.
Of course, of course. We don't want anyone anyone getting into danger zone for with the propellant.
Yeah.
The As you were saying, the satellites now more and more. Before it was just orbiting, so their movement is really kind of just keeping them in orbit. Now we want them to move. We want them to specifically retarget where they're going and also avoid other things. So we're talking more fuel. I guess there's a now the challenge is finding the sweet spot between weight and fuel because if we're getting smaller and smaller in satellites, we're also getting less and less room for fuel. So that's I guess the balance
Well,
you always have to play with.
there's where I'm going to differ because I know it's been talked a lot about a revolution in small satellites. There's so much activity in small satellites, small. Um, but I our perspective where we look at because we see how a lot of these programs develop. They start off with a small satellite,
Yeah.
and then they get it up into space, and they start commercializing it. And all of us, and in almost every case, they realize, oh, we want better resolution, we want more bandwidth, we want more this, more that, and so inevitably, almost always, we see the next version is a larger spacecraft. Well, there's sending out more, but a lot of times they go up to larger. So the physics, I mean, there's miniaturization. There's all that you know process that's happened. But at the end of the day, um, the things that you care about need bigger apertures, bigger antennas, more fuel. So we do actually see things getting bigger.
Okay.
We already see it.
Yeah. Now, so Bradford now, CO, you guys have your handfuls in innovation. Zero Kitchen is your little baby on the side that you saw with your wife. Um, as you mentioned earlier, space was like a really important interest from the get go. I always ask my guests, uh, give me three words that describe space for you. And obviously, from when you were younger, what drew you to space?
Three words to describe space.
Three words.
Broad,
Broad.
um, open, um, opportunity.
Do you think going to space is actually going to bring a lot of benefits for the Earth? There's always people that says one at the expense of the other, and then there are others who say no, it's actually will be at the
Well,
benefit.
I mean, there's a cottage industry that of people that are just say yes, and there's a whole bunch of good reasons for it because television, GPS, telecom, all that stuff. They've sold their benefits. I don't need to resell their benefits. Um, we have a lot of that. I think it's an actually interesting question of when we start sending people and we start going further out. What does that have a benefit? And I have to say yes because um, you know being able to expand possibilities has rarely been a bad thing long term for humanity. It creates can often create issues short term, but it's almost always been to our greater benefit because it means different ways to stack things, ways to look at things, a new way we can do the things and benefit each other,
Yeah.
however way, and benefit can mean completely commercial things. Um, now, is that going to be because we'll have a settlement on Mars, or we'll have the resources of the asteroids, or we'll have laboratories in space, or all of the above? I don't know. I think it's in all of the above,
Yeah.
and I think it's going to take some time for the benefit to really show itself because the earliest beneficial applications of satellites, which was basically telecom slash television and
Yeah.
GPS, those were things that had a very direct benefit because they used the high ground, space as a high ground. It was basically implementing infrastructure for the Earth, but higher up. And it was also very efficient in terms of the space assets versus the benefit. One of the beautiful things about geostationary telecom is that you put up one satellite and it covers a third of the Earth. Um, and if it's broadcast, you don't need your capacity scales with the number of channels you want to send. It doesn't scale with the number of subscribers. Um, these new activities in space require a lot more space asset to do what they're doing, which is why they depend more on bringing down launch costs for them to be valuable. So they do need to come down. There needs to be a robust infrastructure. That launch capacity has to be able to launch more than just satellites.
Yeah.
It has to be able to launch, people in pressurized capsules,
Yeah.
because those are things that you don't have to spend millions to build. They're valuable in millions and more, but you don't. They line up to go to this to space. You don't have to build them from metal. We do need a more robust infrastructure to get to these markets and get to this kind of ecosystem. But we're on our way there.
Giving the opportunity, would you go to space? Have a little
I
trip?
will give you the answer I give everyone, and that's if I need to go there for business, I will
Yes.
go to space.
Ian, where people can find more information about Bradford Space?
Well, first go to our website,
Yeah.
bradford-space.com. That's most of it. You can check my LinkedIn feed if you're already connected to me. Maybe follow me, or you can follow me on Twitter. That you don't I don't have to approve you to follow follow me on Twitter. So Twitter and LinkedIn is where we're at, and we were quiet for a long time, but we're a little more active now, just because I think people deserve to see what we're doing, what we have. There's a lot of money flying around in the industry right now, so there's a lot of hype just on who raised how much. We view it more as how many things have we put into space?
Yeah. And
How
you've
many
put
things
a
will we put?
lot. You've
Hmm?
put a lot.
Over 2,100 products
There
into
we go.
space,
Well,
and many more to come.
many more to come. We look
Many
forward.
more to come.
And I look forward to a meetup on the road. I guess this is what's going to happen in 2022, finally, face to
Yes,
face.
I hope
Um,
so.
And I hope that people will see you also on the road and learn more about Bradford Space. There will
Yeah,
be the link to your LinkedIn and the company in the comments so anyone can visit. And
wonderful.
look forward for testing more cookies from space
Cookies and many other
and many others.
tasty treats.
Absolutely. Ian, thank you so much for being on the Future Space.
Thank you. Thank you for having me. And I hope to see you on the road and anyone else watching. It's a big universe out there. Let's start building. Let's keep building.
Absolutely. Thank you, Ian.
Thank you. Thank you.